Spencer, it's time to stop talking about the virtues of pancakes and kill the lights.
Have you ever been to Country Kitchen?
Yes,
Yes.
but I don't have the pancakes. I don't eat pancakes.
So good.
You don't eat
I'm sure they are. No, I like them. I like them a lot. But the problem is that carbohydrates and I don't agree.
Who cares?
So, yeah, my girlish figure cares very much. So,
Mr. Linguist is curvy.
yeah, there we go. I'm actually hoping to be less spherical. So, that's what we're working on there. Okay, so here's the deal. We've started working on simultaneous equations and inequalities. Last week we did a lot of graphing, and this week we are doing, bless you, a lot of algebraic solutions, God bless, and through Thursday, what we are going to focus on is algebraic solutions with a little touch of graphing thrown in along the way to keep it fresh in your mind. What's that?
What are we doing Friday?
You know what? I haven't peeked that far ahead. It's on the wall, but I haven't looked that far ahead. So, let's go through here and get things going. All right, so. Okay, are we ready? All right, let's get our focus going about us. The first says to solve for x. And if I was to solve this for x, I would put the 4d over 1, and I would cross multiply. And when I do that, I would get 3ax plus 2b equals 4cd. Now, you may have said 4dc, and that's equivalent, but cd, we normally like to write alphabetical order. Yes?
I did C in times, and in parentheses I put 4D. Is that still?
Yeah, that's fine. Yeah, absolutely. Okay, so next up, minus the 2b from both sides. Die. 3ax equals 4cd minus 2b. Then divide by 3a. And yes, it is awful looking. It's terrible looking. It's worse than dog puke looking.
It's trash.
Yes, but it is right. So that's the correct answer. Okay, any questions? End the game. Any questions? Okay, you know, when you think about the quiz that you guys just took a minute ago, and what I noticed is that very few people, God bless, or let me rephrase this, virtually every single person knew how to do virtually every single question. What I saw was details. That the details tracked people, whether it was to write .814 repeating, to not round off, etc. If we eliminated those mistakes of detail type and just went with concepts, I think there were maybe two questions, let alone people, 2 questions out of every question done on the quiz that missed something conceptually. It was the details that got us, the old expression, the devil is in the details. So what I think we really have to do is pay super attention to details. And a lot of times when I'm done making a general point, you guys will turn to each other and start to talk a little bit. And I follow up the general point with the detailed point. And it's the detailed point that you're missing on the quizzes. Okay? So one more time. I cross multiply, I subtract 2b from both sides, and then I divide by 3a. So my correct answer is x equals 4cd minus 2b over 3a. You could write 4dc or put them in parentheses, that's fine too. Any questions? All right, so now let's get to the next question, which is a little bit of a reminder on graphing. And what I would like to do is show you a very quick way to graph things. This is a graph using x and y intercepts, rather than getting it into y equals mx plus b form, okay? So it says the sum of 2 numbers is 25. So x plus y is 25. Now, one way to do this is clearly to subtract x from both sides to get a y-intercept of 25, and to go down 1 over 1, down 1 over 1, down 1 over 1, etc., because that's the slope. But another way to graph, especially if you have something that looks like this, x plus y is 25, is to do what we call x-intercepts and y-intercepts. What is the x value of the y-intercept? What is the x value of the y-intercept?
0.
0, good. What's the y value of the x-intercept? Everybody?
24.
0. No, I didn't ask what the y-intercept was or what the x-intercept was. That would be the right answer. I said for the y-intercept, what's the x value? That's 0. For the x-intercept, what's the y value? That is 0. So if I just very quickly substitute in a 0 for x, I get y equals 25. And if I substitute in a 0 for y, I get x equals 25. So what that means is this. I'm going to let each of these equal
4.
5. 5, 10, 15, 20, 25. 5, 10, 15, 20, 25. And there is my line. So that's a very quick, very easy way to graph a line. When it looks like something x plus something y equals a constant. Okay? Yes?
I can't really see the lines of the graph in my paper.
Guesstimate as close as you can.
Guesstimate.
Yes. Now, so what this coordinate is here is 0, 25, and this is 25, 0. Nice, quick, easy way to graph. I don't know if you remember or not, but when Colonel LaRock was here, that's how he did his graphs, very quickly. Yes?
Would the line ever like be negative? Would it have
The
negative-
line be negative.
Like, would it ever have negative points?
You mean cross into like the fourth quadrant?
Yeah,
Sure,
how?
because negatives and positives can still add up to positives. Okay? Now, if I put this in the context of x represents the number of boys and y represents the number of girls, then no, because you can't have negative boys and negative girls. But unless they give you a context in which negatives are not possible, the line can go on forever. Now, what this means is that this point right here, the point 15 comma 10, or this point right here, the point 10 comma 15, or this one here, 5 comma 20, or this one here, 20 comma 5, and all the ones in between also are solutions for x plus y equals 25. 0, 25, 5, 20, 10, 15, 15, 10, 25, 25, 0, 1, 2, 3, 4, 5, 6. There are 6 combinations, 6 solutions that add up to 25. Okay? And if you look, every time they do, right? 0 and 25, 5 and 20, 15, 10, 10, 15, 25, 25, 0. Every one of those combinations adds up to 25. Okay? Agree? All right. So that's a very quick, very easy way to do such graphing. Now, those are not the only combinations. Another combination is 12 comma 13. Another combination is 14 comma 11, or 11 comma 14. So there are many, many, many different combinations. But this, for quick, easy purposes, sketching with x-intercepts and y-intercepts is a nice, easy way to do it. Okay, so that's everything we've done so far is just review. Now, we do a little bit more review, and I feel badly that you might not be able to see this overly well on your paper, but let's do a quick graphic solution, and then we're going to do an algebraic solution. So this is a problem that is done graphically and algebraically, so you can see how the two are related. Go ahead. I'll give you about, say, 3 minutes, it was too much, 2 minutes to get this done. Bless you. So, I graphed the two of them. I graphed the red one using standard y equals mx plus b. I graphed the blue one using x and y intercepts. And what I notice is that I'm not exactly sure where they meet, because it gets right down near that bottom of the graph there. Did anybody else feel that way?
Wait,
I couldn't go.
I could,
I mean, I could.
I mean, look, we can convert to y equals mx plus b form, but then I'm gonna get y equals x minus 7. It's the same exact line, but the point being that I really can't tell on my graph exactly where these two lines meet at the bottom. It's kind of getting just a little bit congested down there. So sometimes there's an algebraic solution that's a little bit better. And the algebraic solution works like this. The other day, we said to you guys, or we went over with you, the elimination technique. And as soon as I started it, everybody said, oh, I remember this. Everybody who had this Antonacci last year said that. Now, at this point in time, though, there's a second technique. And today we introduced the second technique, and then starting tomorrow, we just keep combining the techniques depending on when each is appropriate. Look, the one we did the other day looks something like this. 3a minus 2b equals blah, and a plus 4b equals blah, blah. And the bottom line is, the a's lined up with the a's, the b's lined up with the b's, and the blahs lined up with the blahs. That's all excellent. When you see that, you do elimination. When you see that lineup, that alignment, you go with elimination. Is such alignment present on this one? Is this alignment present, yes or no? No, so we go with substitution. So look, a y, yes, you should have, is worth a 2x plus 1. So instead of the y, I'm going to put a 2x plus 1, because a y and the 2x plus 1 is the same exact thing. Boys, who is the prettiest girl in the world?
John Cena?
J-Lo. J-Lo?
J-Lo. Ariana Grande.
J-Lo.
So listen, considering Ariana
Gigi
Grande
Hadid.
is more
Gigi
your...
Hadid.
So Spencer, listen, if
No,
Ariana
it's
Grande is...
Gigi. No, it's Gigi.
Can you stop?
It's Gigi.
All right. If Gigi's exact identical twin came to your door and asked you out on a date, are you saying no?
Yeah.
No, you lie like a rock. Girls, who is the most handsome looking guy on the face of the earth?
Right here.
All right, if Zac Efron
It's
comes to
Kyle.
your house and asks you out on a date,
No, it's Kyle.
let me rephrase that. If a 14-year-old Zac Efron
Okay,
comes
yeah.
to the house and asks you out on a date,
All right, no.
are you gonna say,
If
Like
no.
high school.
Are you gonna say no?
I'd say no.
okay. Now, equals can be substituted.
You know that.
Spencer. Equals can be substituted for equal. So, since a y is worth the same thing as a 2x plus 1, instead of the y here, I put what it's worth, which is a 2x plus 1. So now I distribute, girls. This was supposed to equal 7, I don't know why I was lying. So x minus 2x is negative x minus 1 is equal to 7. Add 1 to both sides. Negative x is equal to 8. If I divide by negative 1, I get x is negative 8. So, as you can tell, I was slightly off when I tried to find that point of intersection. I really couldn't tell. It got off the graph, and that messed things up. I'm still not done, though. X is negative 8. Y is 2 times negative 8 plus 1. So y is negative 16 plus 1. Y is negative 15. So, we have now covered the two techniques that we have for algebraically solving a system of equations. The other day we covered elimination, today we covered substitution, and then for the next 3 days, we will go back and forth between these techniques with a touch of graphing thrown in there to make sure that we can handle all situations and types thrown to us. Any questions? How many people remember substitution from last year?
Me.
Very good, okay.
Oh, it's like burning the board.
Yes, it's letting us burn the board. Spencer, hit the lights.
All light.
I would bring it to the main office. I don't know anything about it.
I'll do it next time.
It's about 9:03 right now.
Look at Ryan's hair.
Chloe, it's nice to see you're back up to snuff with the dressing. Very important. When you don't dress right, it really, I mean, every morning I look at my closet and I look and I say, what combination will go? Like, today I had on a green turtleneck at first. And then I looked at my green sweater on the green turtleneck and said, this will not do. So I switched to a contrasting color to go with it, knowing full well that if I had screwed up my proper dressing technique, I would be disappointed.
Can we find the highlight?
You're very consistent. You have very
I am all over it.
Roast it.
Listen, you've made a series of mistakes, so what I'm going to do is I'm going to make up a new one, and I'm going to go over that one with you. You're going to take it home one night, and we'll probably tomorrow night, and then you're going to bring it in, and we're going to go over it Thursday and next month, step by step by step. Make sure we got it, all right? And then we'll redo the retest.
Thank you.
You're welcome. Have a good one.
You too. Your outfit looks like Christmas.
That, you know, and that was in my mind, and I have a Christmas tie coming next week. All right. How'd you do in your volleyball game?
I'm not in volleyball.
You were in the hole a little while ago.
Oh, we weren't playing volleyball. We were playing monkey in the middle.
You play, oh, monkey in the middle. Ah, okay. How's your sister?
Good.
Nice. Mom and dad?
Good.
Good. Ah. Let's go. Grab a sheet, grab a seat.